Our first theorem is something that applies to the calculation pattern that we did on the board and on your notes a few days ago. Remember how we had one triangle. Let's move over here. Then one triangle, we colored all triangles, right? We traced it and colored the associated angles on your paper, or in my case, the board. Then we rotated it and colored the corresponding angles of the colors. Always had a specific order they went, right? So because I couldn't print in color, I can only put in black and white, I do textures on this one. We have the solid, the striped, and the polka dotted. Now look what happens when we rotate the triangle. Would you agree that all three blue angles are, I guess there are four. All four blue angles are congruent. Because we're all tracing the same triangle, right? We're tracing the same exact triangle every single time. So, what does that tell you about these polka dotted angles? The congruence, that's the word we want to use. Only is a congruent. Okay? And same with the black, right? Now that's what happens right here. When we rotate it 3 times, we get a special type of angle right here that is made up of all 3 angles. What type of angle do we do right there? So we're looking for some 2 angles. A straight angle. A straight angle. There's a line, is it not? Yeah, we know straight angles add up to 180 degrees. So look at what made up those 180 degrees. How many angles to our triangle created that straight angle? All 3. The polka dot, the stripe, and the solid are all part of that, and together create a straight angle. So all 3 angles from the triangle have to sum to how many degrees? Not 60. 180, because it makes a line. You can see all 3 of them right here. Make a line. All 3 of them together make a line. So that means any triangle, just any triangle, because we all did different types of triangles. Any triangle, all 3 angles sum to 180 degrees. That might be information you already know from maybe elementary geometry, but they just told you that. Here, we proved it visually, geometrically, I guess, with a tessellation. So that's the first theorem. It's called triangle angle sum. Triangle angle sum theorem. Triangle angle sum theorem. That is given any triangle, all 3 angles sum. What does sum mean? Add up to the answer to addition? No, that's different. Sum is addition. Add up to 180 degrees. Okay? Our next theorem. Well, you already told me that you agree that I'm going to look at the first 2 triangles. This blue triangle is congruent, or that blue angle is congruent to this blue angle, right? So they came from the exact same triangle. And this polka dotted angle is congruent to this polka dotted angle, right? So they came from the exact same triangle. So 2 angles are congruent, 2 pairs of corresponding angles are congruent. What do you think that tells you about this 3rd angle? Please stop talking and look this way. I just asked you a question. What was the question I asked? I don't think that was what you were talking about. Then tell me the question I just asked. Okay, then what was I just drawing on the board? No, that wasn't what I was drawing. I was shading in angles. Why is it shading them in? What did I just talk about the angle that shades in? The blues are all congruent. The two corresponding angles are congruent. The two polka dots are congruent. So two pairs of corresponding angles that are congruent. What does that tell you about the third angle? Meaning the black striped angle. Who can prove it algebraically? If say maybe the blue one is 65 degrees and the polka dotted one is 70 degrees. You can prove it algebraically that that black one, no matter which triangle, is congruent. Jeff? Okay, so how would I show that? What is 70 plus 65? 135? So 180 minus 135 tells me that black striped angle would have to be 45 degrees. Would this black striped angle also be 45 degrees? Don't throw things. Go pick it up, please. Go pick it up. Don't throw things. Would the other black striped angle also be 65 degrees? Or 45 degrees, excuse me. We can prove it. How do we know it's 45 degrees? So we know in this triangle, the red one, I'm sorry, I'm in the middle of a sentence. Raise your hand if you want to answer that. This red polka dotted one was how much? 70, because we already told it's congruent angle. And the blue angle was how much? Also 65. Since these are actually subtracting the exact same numbers, yeah, so you get 45 degrees. This is one that will probably pop up on your map with Excel assignment on the proofs. It's called the third angle theorem. If you have two corresponding congruent angles of two triangles, then the third angles have to be congruent. So on the theorem, pick up your pencil, please, don't just sit there. And it's called the third angles theorem. Okay, again, it comes from given two triangles with two corresponding congruent angles. Given two triangles with two corresponding congruent angles, the third pair of corresponding angles must be congruent. Given two triangles with two corresponding congruent angles, the third pair of corresponding angles must be congruent. Okay, down below, corresponding sides and corresponding angles of congruent triangles. We just talked about corresponding angles. Corresponding angles mean they have to be in the same position on the triangle. Now, there's an order to how we list the letters of the triangle. We kind of talked about this last time when we were talking about hypotenuse length theorem. This back group, the boys, okay, so please pay attention. You two boys, I need you to pay attention this way. Okay, the first, if we're to name these triangles, we have a triangle symbol in front of them, just like when we name an angle, we put an angle symbol in front of it. Let's name this first triangle. We could really name it anything we wanted. But typically, we put it in alphabetical order. Brian, can you tell me that triangle on the left or the alphabetical order of those letters would be? A, B, C. So this is going to be called triangle. The triangle symbol right there. A, B, C. Write it down, please. Okay, now it is congruent to another triangle. Okay, but one of the postulates on your folder, which we'll talk about postulates in just a second, so I'm going out. Okay, now the second one, the order you have to be careful on. The first one you can put really in any order. The second one you have to match up corresponding parts. So, angle A is created by this side that has 2 tick marks and this side that has 1 tick mark. What angle on the other triangle is created by the 2 tick mark and 1 tick mark side? Yeah, E, A, D. So angle A, that middle letter is the angle. So A corresponds with A. B has to correspond with, well, B is created by no tick mark side and 1 tick mark side. Which angle over here is created by no tick mark and 1 tick mark? Good. D. And then, lastly, C is created by no tick mark and a double tick mark. So that one would have to be E. Okay, the order tells you corresponding sides and angles. On your foldable, let's determine how we actually know that these are congruent. I see on here the marking, a pair of congruent sides, and another pair of congruent sides. We have 2 sides that are congruent. Is there anything else we know about congruency on that, AJ? Exactly. When there are 2 lines that intersect each other, the opposite angles, or these ones right here, are vertical angles, so they are congruent. To show that, you would do a matching arc. You can also sometimes do a matching arc with a tick mark in it. So, as you rotate around the triangle, which one of ours listed on our foldable is the postulate that proves that these triangles are in fact congruent? Everyone remember last time? So you foldable? Now, as you rotate around the triangle, so instead of one end, rotate around. In order, we get side, angle, side. S-A-S. S-A-S. Okay, that's how I know they're congruent, by the side angle side postulate. Okay, now we're going to list all the corresponding sides. Corresponding sides, you can look at the markings on the triangles. You can also look at the order of these letters. And then work on the order of the letters. A, B, if this is a side, what do I need to put with the A, B so I know it's a segment or the length of the side? A line on top, good. Okay, it's congruent too, so we need to put the congruent sign. A, B is the first 2 letters. What's the first 2 letters in the other triangle? Because we carefully put them in the right order. A, B. So those correspond, and they are congruent sides. Next, I'm going to move over to the last 2 letters. The last 2 letters would be congruent to the other last 2 letters, right? So we did the first 2, and now we're doing the last 2, B, C, and what's the other one? D, E. Make sure you put a marking of what it is, so we put a segment bar above it. Now, this is a triangle, so I should have, you said you were going for a drink. No, you said you were going for a drink. You've been gone now for 25 minutes. Sit down, Chris. Okay, what am I missing? We did the first two together, we did the last two, and what's the other way that we can arrange these letters? The first and last, the outsides. So A and C correspond to which segment of the other triangle? What's the outsides? A and E is an elephant. A and E. That's how you list heads and corresponding sides. Okay, since it's a triangle, triangles have two sides, you should find that you have three pairs. Okay, read the comes out, please, and catch up on what you've missed. Corresponding angles, same idea. Angle A, I put an angle sign in front of it to show it's an angle. Versus on the side, I put a segment above it, and if it was a triangle, it gives us a triangle in front of it. So you need to draw the symbols so you know what you're talking about. So would you please catch up on what we have on the board? Angle A is the first letter here. Okay, what's the first letter over here? Angle A. But are they actually different angles? Colby, come sit up here, please. Are they actually different angle A's? So that's confusing to have two different angles called angle A. So I be more specific. We can actually call angles by three letters, but the vertex has to be in the middle. This first angle A is this angle. Who can give me three letters for that angle with the vertex in the middle? Right? Let me figure that out. What are the three letters with the vertex in the middle? There's two different ways to say it. Okay, no, it's the one in red. There's no L's with that, or M's. Yeah, C, A, B. Or the other version is B, A, C. That vertex A where the two lines come together has to be in the middle. So my corresponding angles, to be clear which one we're talking about, I'm going to do the three-letter naming C, A, B. Now my other angle A, and two angle A's, it should be more clear. Okay, now what happens when we name this other angle A? Good. Angle E, A, D. And the vertex A, or the point of that angle, is in the middle. We'll start writing. Okay, next. Angle B. Angle B is the middle angle. Okay? Our angle B has to be congruent to which angle? Because they're both the middle letters, right? Angle B, and they're corresponding as well. Angle C, then so angle C is congruent to what? To angle E. Okay, that's how you list coordinate sides and angles. Notice in each category there are three listed because an angle or a triangle have three angles, triangles have three sides. Okay, now down below, knowing that the order of the letters given here is important, we're given that they're congruent, we can list corresponding sides and angles. Now this time, the pictures are kind of skewed in different ways, so there's a couple different ways you can do it. One, you can visualize turning one of the triangles so it's in the same way as the other one. Or you can just look at the order of the letters, and it's actually pretty straightforward. If I look at the order of the letters, EF, Kenneth, what side is congruent and corresponds to EF? KL, yep. Because it's first two and first two. KL. Okay, Tyson, can you give me another pair of congruent sides? FG, that's the last two. letters listed, so that has to correspond to what, Mason? Good. Last two, LM. Okay, we've done first two. Last two, this is the one sometimes people forget. What's the other option? Yeah, the outsides. EG. Or GE is the same. With what's the property, they're the same. The outside EG has to be congruent to plate M. Okay? Let's go through and let's pair the corresponding angle, please. For the order of how they're listed in the congruent statement tells you what matches. Okay, list your angles. Angle E is congruent to which angle of the other triangle? Okay, Kevin, do you have one pair of congruent angles for me? Yep. Angle E. E is the first letter, so angle E is congruent to the first letter, angle K. There's another pair of congruent angles. Okay, one. Yep, because F is in the middle and L is in the middle. Who was the last one? Right? Angle G is congruent to angle M, because those are the last letters listed. Okay? So when you learn all the letters in congruency stage, you actually have a lot of information. So when you're asked to write a congruency stage, you have to be careful of the order in which you write them. Okay, flip it over. Okay, we're going to be specifically looking at three different types of triangles. Most of the time, here will be on isosceles triangles. First of all, what does an isosceles triangle look like, or what type of properties does it have, Brian? Yeah, so two equal sides, and it could be one unequal. So something like that, right? Let's go back it over, please, on the next page. Okay, so I have a triangle over here that looks like an isosceles, but until we actually read to give it information, we won't know for sure. Advance it up, please. All the way up. Thank you. Did you draw the triangle, Isaiah? With the tick marks to show it's an isosceles? Do that, please. Given xy is congruent to xz, is that on our triangle that we have an xy and an xz? Yeah. So how would we show the xy congruent to xz? A tick mark. Do I do one on one and two on the other? No. Are you matching, right? One and one. This part of the given says xd bisects angle yxv. What's the middle letter of this angle? So that's the vertex. So we're really looking at angle x. This angle. Angle x. What does it mean to bisect that angle? Okay, interesting. So if I cut the angle in half, I'm going to do a dotted line to show that. What does that tell me about this angle and this angle? They're congruent, because we just cut it in half. So we're trying to prove that these bottom angles, y and z, are congruent as well. So this way the information, somewhat what was given in our two-column proof, and then another thing you just discovered that wasn't on the given, we're going to write that in our proof. So remember, the left-hand column is statements, the right-hand column is your reason. First, the first marker we did on the triangle was x and y, xy being congruent to xz. xy is congruent to xz because that was given. What's the next thing that we do in a triangle? First, I put 2 little red tick marks to show that those were congruent, both sides. What? We bisected the angle. And how do we know we're allowed to do that? And it looks like XB, so down here should be B. How do we know that XB bisects the angle? Given. So XB bisects angle YXZ. Given. Remember, this is just like an Uno proof. So one side, you state the card you're going to play, or the thing you're arguing, and the other side, you prove why that's allowed. Give the rule why it's allowed. So sometimes they're given. Then, you told me something that wasn't given. You don't need to do something about these 2 little angles. Why do we know they're equal or congruent? Because that's what a bisector is, right? So definition of a bisector. Now we can't call both of these angle x's. So to be more specific. So this first angle, what can we call that first angle? YXB. Angle YXB. Make sure the x is in the middle is congruent to the other angle. Brianna, what's the other angle on the right little triangle? Because we essentially made 2 little triangles. What? I need 3 letters for the angle. Yeah, and the axis is being go. So BXZ. Angle BXZ. And that was just by the definition of an angle bisector. Interesting. So now we have 2 little triangles with 1 congruent side and 1 congruent angle. We have a side and an angle. That's starting to sound like an S and an A. What else do we know about these 2 triangles? Well, all of the ones that are congruent, you have 3 letters. I have an S and an A. Can we come up with another congruent angle on our side to use one of our postulates in our problem? Yeah, XB is congruent to BX. Don't they share this bisector? They both have that as a side length, correct? Yes or no? Yes. So, what property did we learn a few days ago that anything is congruent to itself? Good job. You're right. The flexible property. XB is congruent to BX. That's number 4. XB with a segment above it is congruent to BX. Anything is congruent to itself. The flexible property. So now we can say that triangle YXB is congruent to the other triangle by which one? We have a side, we have an angle in the middle, and then another side. Which one is it on our problem list? Side angle side. Side angle side. However, when I write this triangle, when I say the triangle, I have to be careful. Y corresponds to which congruent angle over there? Z. X corresponds to X, right? And B corresponds to B. So make sure you get that second one in the right order. So if I know that these 2 triangles are congruent, does that prove what we wanted to prove, that Y and Z are congruent? Yeah, because corresponding parts of congruent triangles are congruent. So angle Y is congruent to angle Z by corresponding congruent triangles are congruent. As we've listed, on the front page, we found corresponding sides that were congruent, corresponding angles that are congruent. But in the triangles that are congruent, corresponding base angles, y and z, have to be congruent. So we just actually proved our theorem down below. This is an isosceles triangle. We just proved that y and z are congruent. Where is the location of angle y and angle z? So, okay, across from each other, and where on the triangle are they? On the bottom. Are they in the basement, maybe? The base. This is called isosceles base angle theorem. Isosceles base angles theorem. Isosceles base angle theorem is given any isosceles triangle, the base angles are congruent. Given any isosceles triangle, the base angles are congruent. Isosceles base angles theorem. That's a handy one to know. The converse of that is go in the other direction. Given, instead of knowing it's isosceles, what would the other direction be? This said, given isosceles, the base angles are congruent. So if we switch the order of those, given base angles congruent, we know the triangle is isosceles. Okay, this is what I call converse. Given base angles of a triangle are congruent, a triangle is isosceles. Okay, so that's the converse theorem of isosceles base angles. The last theorem on here is a relationship that happened, and we've actually, since we proved that those two separate triangles were congruent, and we have this angle bisector. I'll scroll down just a second. This segment and this segment, what do you know about those two? They're congruent because we proved the triangles are congruent. And any idea what the intersection of the base and that base angle or that bisector is? What? The intersection, XB with the base of the triangle. They intersect each other at a special angle. I'm writing. That's the last theorem. I don't really have a nice pretty name for this. Your book just calls it theorem 20. Yeah. Okay, theorem 20. If a line bisects the vertex angle of an isosceles triangle, if a line bisects the vertex angle of an isosceles triangle, if a line bisects the vertex of an isosceles triangle, then the line is also perpendicular to the base. Then the line is also to the base. Okay? So the line is also perpendicular to the base. We're only going to do a couple that we're going to jump around for the rest of the notes, a couple here and there to make sure you know how to solve. Right triangles. What does the right triangle have to have? An angle. Okay? We know the hypotenuse leg theorem. We already talked about it last time. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of the other triangle, then the two triangles are congruent. So there are three things that have to happen. One, you have to have two right angles, or right triangles. Two, the hypotenuses, I don't know how to say that plural, hypotenuses, hypoteni, are congruent. Three, a pair of legs are congruent. If that all three of those happen, then the triangles are congruent. So, number 4, first thing, are they both right triangles? How do we know they're both right triangles? So, they have the square, right? So, right triangle, check. Is the hypotenuse congruent? The hypotenuse from the longest side is across from the 90-degree angle. Those both are twins. So are they congruent? Yes. Congruent. Next is the leg that is congruent. Corresponding leg. 6, and if I rotate this one, 6. So are these congruent? Yes, and then I want to look at a triangle congruency statement, which means name them and make sure you're correct on the order. Isaiah Cooper, can you give me a name for the first triangle? What's the first triangle called? There's letters on it. I need them in alphabetical order. A, B, C. Because Kevin would be a pentagon. 5 angles. Kevin, not a triangle. Okay, it is congruent. This is our congruency statement to a triangle. Now the other one has to be in the right order. Which angle is actually corresponds to A? D. Can you go visualize turning this? D is the right angle, so what's the right angle over here? E, and then S. That's the triangle congruency statement. Number 5, and then we're going to skip 6 and 7. Are these congruent? Let's see first. Is it a right triangle? Are both right triangles? And the answer is yes, but you can tell me why. He answered the same thing, the same reasoning he gave us before. Vertical angles. So therefore, both of these are right angles. So they are both right triangles. Do we have two hypotenuse that are congruent? Can you see the double tick marks? Do we have two legs that are congruent? Yeah, you see the single tick mark. So we're going to say yes, and let's write the congruency statement. The first one can be written in any order. Isaiah Cooper, I'd like the first one in alphabetical order, please. The one on the left. And P. Whoops, not me. P. It's congruent to a triangle. What goes with L, Aspen? L is created by the 2 tick mark and the 1 tick mark coming together. Okay? N is the right triangle, the right angle. So M again. And then N. Okay, flip it over. Let's look at the I think it's equilateral. These ones, you probably already know these theorems. Equilateral means what special property does the triangle have to have? All equal sides. So that marking would be tick, like that. Corollary, if the triangle is equilateral, then the triangle is equiangular. Equiangular means all angles are equal. All three angles are congruent. And if we know a triangle adds up to 180, all three angles have to be how much degree? 60. 180 divided by 3 is the measure of the angles equals 60 degrees. All of them. 60, 60, and 60. The other corollary is the reverse of that. If the triangle is equiangular, so if we have three equal angles that correspond to each other, have two triangles, then it's an equilateral triangle. Okay, we're just going to do a couple of these. Let's start with number 10. Find the values of x and y. Second, what do you notice on this picture? Okay, what kind? And how do you know it's isosceles? It just works that way? Yeah. We can't go that way. We always have to prove why. What description of the fit? Two short little lines. So it shows two congruent sides by those 2 marks. That's what you need to tell me. Okay, so we know it's isosceles. And we learned a special theorem about isosceles triangles today. We're trying to find angles x and y. We learned a theorem about the angles of isosceles triangles. Isosceles base angles are congruent. Okay, so we know that this angle is congruent to this angle. But we don't have any numbers down there. I do have a number right here, though. How do you know it's equal 70 degrees? Yeah, these two right here are supplementary angles, and they make a linear pair. So we do 180 minus 110 tells you that bottom left angle, base angle of the triangle, is 70 degrees. And by our isosceles base angle theorem, this angle on the bottom right is also 70 degrees. So we know y is 70 degrees. Make sure you have a degree because it's the measurement of the whole angle. What's the measurement of angle x? How do you know it's 40? 70 and 70 make 140. And we know a triangle adds up to 180. So the left remaining triangle has to be 40. Good. That is this is called an exterior angle. And that with the interior thing will make 180 degrees. Okay. So I think there's one last one on the back I wanted to do. Yes, number 14 on the very, very back. Well, number 14. Find the values of x and y. For where x and y are, they can go by hypotenuse length. Okay, hypotenuse length is only applied to right angles. Are these right triangles? Yes, so we can start with the hypotenuse length. So the hypotenuse, I need to learn how to say that, is congruent. They should be congruent. So that's the hypotenuse. What's the hypotenuse on the other triangle? 3y. So these two, if they're in fact congruent triangles, should be equal to each other. So I'm going to take x plus 3, and I'm going to equal it to 3y. So they're congruent parts. Write it down for this 14. Now, one way we should solve it, we have an issue here. We have two unknown variables and only one equation. You can only solve for two variables if you have two equations. If we have 3 equations, we can solve for 3 variables. If we have 10 equations, we can solve for 10 variables. I wouldn't recommend doing 10 by hand. That would be awful. Okay? So we need to get some more information so we can build a second equation. So we have hypotenuse should be congruent. What else should we know about hypotenuse leg theorem? Well, we're going to have a right angle, but we're trying to find x and y, which are on the legs. The legs should be congruent. This side should be congruent to this side. So if they're congruent, we should be able to have them equal to each other. X equals y plus 1. Okay, that is way more advanced math to do in what's called a matrices. Really, this is just a simple systems of inequalities. If you already know what x is, you're just going to plug in one equation into the other. In this case, we already know what x is. So the x on the top equation, what can I replace the x on the top equation with? Y plus 1. Y plus 1. And then the rest stays the same, plus 3 equals 3y. So this x in the first equation was just replaced with what we learned x was. X was y plus 1. Now everything is in terms of y. So we can find what y is. We don't have any more x's. That's a nice thing about substituting in one equation into the other, is it gets rid of one of the variables. Okay, so how would you start solving for y? There's nothing being timed, so we don't distribute. Well, if you minus 3, it comes over here to y side. I want to get all my y's together. I want to subtract y over there. You want to move the smaller y. That way everything stays positive. So my y side is going to be on the right. And I have 1 plus 3 equals 2y. 1 plus 3 is 4. How do we get y by itself, Aspen? Yep, divide by 2. So y equals 2. Okay, but it wanted us to find x and y. We just found one of them. Do you have an idea of how we can find x now that we know what y is? Right here. And y is going to be what number? 2. We just found 2. Technically, you can plug it into either one you want. You can plug it into the top one or the bottom one. It just so happens that the bottom one is a little simpler. Y is going to be replaced with 2 plus 1 tells us x is 3. And those are the values that make these triangles actually congruent by hypotenuse leg theorem. Okay, because it's a short day, I'm going to do your homework in reverse order of what other classes are doing. So instead of giving you the math Excel assignment, this one has extra credit on. Your homework is 5 proofs. The even proof. Evens are required. If you do the odd proofs correctly, then you get extra credit. Now please listen. There's extra credit available on this, but in all of them, you should be thinking about using properties like the reflexive property. What is the reflexive property? And it doesn't have to be a line, or it doesn't have to be equal, it could be either one. If it shares something, anything is congruent to itself. You should also be thinking of vertical angles. You should also be thinking of if there's parallel lines, any of our angular relationships we can exhibit on the board, and any of your, if there's triangles, see if you can prove them congruent in your postulates from your table. Okay? So, a reminder on your duties of Math Excel, On Friday, tomorrow, that's not your seat. Come back over here, please. Friday, by 11:59 p.m., what's due on method solve? The first one, ratios and proportions. It closes at 11:59 p.m. The one on triangles and the second one on triangles, you don't have to do that. The first one on triangles, sets an AOC. The triangle progressing one using your foldable, that one is due on March 3rd, which is on Tuesday. Okay? So your first, this one has 5 problems on it. It's not too much. Proofs take slightly longer, but it's not too much work. You should make sure your first priority is to get either relationships done by, or ratios and proportions is the assignment, sorry, by Friday at midnight. It's extra credit. Listen, many of you should think about doing the extra credit. We'll have operational fail today after school, every Tuesday and Thursday. They also have operational fail every Monday and Wednesday. Wednesday mornings right next door. Monday mornings in Mrs. McDonald's room. Today after school is Tuesday, Thursday in my room. I have, if you need to redo the test, I have a packet for you. You have to come in twice. The odds. The odds. Operational fail is also extra credit, because if you work for the 2 days and do it, and then you get operational extra credit points. Okay, have a seat. Colby, your seat's over here. Colby, come back here, please. Can I have a seat, please? Sit down, please.